Hello, everybody, and welcome to this week's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute, and this week we've got another awesome hangout planned for you. What else would we have? We always have awesome hangouts. This week we're going to be talking. We have members of NASA's Dawn mission available on hand, as well as the Hubble Space Telescope, to talk about minor planets and asteroids. In particular, we've got the NASA Dawn mission is currently en route to reach the minor planet Ceres early next year, and we're going to get an update about what's going on, some of the science goals that the team hope to learn, as well as how Hubble played a role in some of these observations, as well as some of the science that they're hoping to get done from this mission. But before I get to the introductions, I want to remind you that on the event page of this event on Google+, we have links to Jason Calorai's academic minute. The voting closes on Friday. We hope you'll take some time out to click on the link, and if you liked his academic minute, he is up for a Listener's Choice Award, and the subject of his academic minute was exploring exoplanets. So I hope you'll take a minute and go there and vote. It would be a great show of support for both the Institute, Jason Calorai, and JWST. So please do that.
And Jason Calorai is a really nice guy too. So
he is.
For anything else, because he's a nice guy.
Yes.
I definitely recommend voting for him.
Right. Okay, so with me today to discuss all of this fun stuff is Dr. Jianyang Lee. He's been in many hangouts with us. He's talked to us about comets, and today he's here to talk about minor planets. Hi, Jianyang. Also with us is Max Mutchler. He is our Hubble data extraordinaire. He handles all the Hubble data. He's my colleague at the Space Telescope Science Institute, where they are enjoying lots of snow, and you can see it in the background. Hi, Max. And also Keri Bean from the NASA Dawn mission. She's at Planetary Keri. Hi, Keri, and welcome to our hangout. Before we get started, Scott.
Yes.
How about you tell everybody how they can interact with us? You're driving the internet on assignment at
I'm kind of driving the internet. So we are here live at NASA's Jet Propulsion Laboratory. If you want to interact with us, you can do so on Twitter using the hashtag Hubble Hangout. You can also leave comments on the Google Plus event page. We will be checking those there using the Q&A app, which is available on Google Plus and YouTube. So on the bottom left-hand side, as you're watching this, no matter where it's at, where it's embedded, you'll be able to pop open and you can ask us questions, and we'll allow us to answer them on air. And then also there are the comment sections on YouTube. So we'll be monitoring all of those because we love being able to answer your questions that are relevant to the topic at hand.
Oh, you only want relevant questions now.
Relevant questions. But if you have ideas for future Hangouts, please let us know there too, because we love getting new ideas for future Hangouts.
And we also are remiss when we always forget to do this, but please, if you want to learn more about these Hubble Hangouts, subscribe to our YouTube channel, youtube.com/HubbleSite channel, and you will find out all about these upcoming events every single week. We have them every Thursday, although today we're doing it a little bit early. So let's get started. Let me start with you, Keri. What is Dawn? What's it hoping to do? Where's it going? And what's its current status? In that order. Right. I'm just kidding.
Yes. So, to help me out, I'm actually going to call in Dawn. I have a nice 25 scale model here. And so this is what our spacecraft looks like. And
I'm taking it with me, by the way.
So we launched in 2007, and we flew by Mars in 2009. And then we got to the asteroid Vesta in 2011. We left in 2012, and ever since then we've been cruising on our way to Ceres, and now we are knocking on Ceres doorsteps. And so we are hoping to use all of the lovely instruments up here on the top of the spacecraft to unlock Ceres secrets for us.
When will it arrive in Ceres?
Arrival is somewhat of a complicated question for us because we have an ion propulsion system, and so our dates can shift a little bit, and we're a bit more flexible than a normal mission using chemical propulsion. So
you got to tell us what ion drives are now.
Yes, well, of course, it's totally like sci-fi.
It is. It's freaking awesome.
Yeah. So actually, you can see one of them here. we have 3 of them on our spacecraft. And I mean, it's totally a sci-fi concept. If you think of TIE fighters from Star Wars, it stands for twin ion engines, and we do them one better because we have 3. So.
And you can aim better than TIE fighters do as well. We know how horrible TIE fighters are at aiming.
Yes. So use these ion propulsion to move us around the solar system, and it's a very graceful, slow movement. Chemical propulsion, you fly there as fast as you can, you slam on the brakes, whereas us, we're just kind of slowly dancing through the solar system, matching the speeds of the bodies we're trying to visit. So it's pretty interesting, the kind of difference in timescales and the way that we operate the spacecraft compared to other missions. And so using this, we actually start our Ceres sequences on December 26th, so just a couple weeks from now. We'll take our first set of optical navigation photos in the middle of January, and we finally beat Hubble resolution at the end of January on January 25th, where we will get 1.4 times Hubble resolution. So we're looking forward to
But
that.
no one's counting over here at all.
Yeah, that's an important date, and we're going to come back to that in just a minute. But right now, I'm showing a quick overview of the path that Dawn has gone through since it launched in September '07. And as Keri said,
so you'll also notice it's got Earth and Dawn as they are right now, and you'll see it's almost a straight line between Earth and Dawn. And so right now we are in what's called solar conjunction, and that means we can't talk to the spacecraft as nicely because the sun kind of gets in the way and it's noisy. But it only lasts a few days, and in a couple days we'll hear from it again.
So the sun, the Earth, and Ceres are all in kind of a line right now.
Yes.
Okay, and that's
and that's not an omen. Don't worry, YouTube commenters. It's nothing.
Oh.
Yeah.
Really, you sure? Because these alignments.
No portents of things to come.
Well, good, but this alignment is preventing you from really communicating with the spacecraft, though, right?
Yeah, we can hear from it a little bit, but we don't have a really good connection with the spacecraft. It's kind of like there's a lot of interference on the line. So, but just in a couple days, we'll be far enough away from the sun that it won't be a problem.
So because of the ion drive, this thing has been at it for a while. It's been up in space, and one of the things I find interesting is what you say is you sort of try and match the speed of the object you're going to go in orbit around or visit, and instead of just blasting there as quickly as you can, other than patience and a good understanding of Newtonian mechanics, are there any other challenges involved with doing that? I mean, to me it would seem like just getting there would be the punchline. That'd be the best part. Is it cheaper, for example, or are there any advantages for doing it this way versus the old-fashioned way?
So the advantage of doing this is for less fuel, you're able to visit more bodies. And so we're basically getting 2 missions for the price of 1 right now with Dawn. We are the first spacecraft ever that will orbit 2 different bodies. So I think that's really cool that this ion propulsion technology has really enabled us to do these interesting missions.
Cool. Okay. So, Jianyang, let me ask you. You are involved with Hubble observations of Ceres, correct?
Yes.
And so, what role did Hubble play is Hubble playing in all of this?
Well, Hubble actually, before Dawn gets to Ceres, we want to know as much as we can about Ceres in order to do our planning work. And that's what Hubble comes into play. And the advantage of Hubble is that Hubble has the best resolution we can ever get. Now, right now, some people will say, okay, ground-based, there are some very large ground-based telescopes that can give us good resolution. But Hubble, although it's not as large as those large ground-based telescopes, it's above the atmosphere, which is a really, really, really good advantage over those ground-based telescopes. So Hubble will give us very high resolution image of Ceres in a very stable condition. So I would say that so far Hubble observation of Ceres, Hubble images of Ceres in particular, give us the most knowledge about what the surface of Ceres looks like before Dawn gets there.
Okay,
and
Scott?
then based on these Hubble images, we will be able to do a lot of planning work.
Okay, great. So Scott's got an animated GIF going of some early observations of Ceres back in 2003, 2004. Is that are these images you were involved in?
Yes, I was actually fortunate enough to get involved, to get the chance to analyze this data when I was still doing my PhD, and that was like nearly 10 years ago.
Wow. So and we've got more recent observations somewhere, I believe. Correct?
Well,
is this the only observation?
Yeah, this set of observation are still the best image of Ceres.
Okay.
Because this set of observation was taken with the high resolution channel on the advanced camera for survey of Hubble, and that channel is not working anymore.
So Max, describe for us this data here that you were instrumental, I think, in getting some of it processed. Correct?
Yeah. So I kind of came late to the game here. I wasn't directly involved. I was not a co-I on this program back in 2003, 2004. It was actually a telecon that I was in with Jianyang much later, like in 2005 or 6, I think, when he mentioned that, a typical program produces lots of data, and he was using some of it. There was also some, as you mentioned, some high-resolution channel images where there was a subsampling dither box used, which means we dither the telescope, make small little shifts to sample an object better, and you can actually get better image resolution in post-processing of the image if you do this strategy. But then it's very kind of tricky to put the image together. So I realized that now this was just we were sitting on the best image of Ceres ever taken, and but it was going to take some work to really put together the image that you see there, and I kind of made a mental note to myself that, I should go get that data and do something with it. It's been sitting there for a couple of years, and see if I can produce, the highest resolution image. And then I didn't really get to it right away. But a few months later, this was the summer of 2006 when the IAU was voting on what is and isn't a planet. And you might recall that the original proposal was going to be inclusive, include Pluto, and you may not recall that it was going to also include Ceres. Ceres was on the brink of planethood in the summer of 2006, it seemed.
But it was denied.
So I realized, well, if Ceres is going to have its coming out party, and we're sitting on the best image, we better do what we can to generate the best image and make sure it's out there on the day that it becomes a planet. Well, you know how the story ends. There was an alternative proposal that was put forth, and a more exclusive definition of planethood that excluded both Pluto and Ceres. And so nonetheless, it was great to put out the best yet image of Ceres, and we literally put it out on the day of the IAU announcement in the summer of 2006, kind of quietly. We weren't trying to politicize the image or suggest one way or the other that this image would determine whether Ceres is a planet or not. But nonetheless, to me, it would have seemed almost irresponsible of us to be sitting on the best image of Ceres, and the world can't see it on really the biggest day in Ceres' life, right, to date. And so I was very proud that we were able to work on that data and generate that image from the older data, which I think Joel Parker and Lucy McFadden and Jianyang had been working on for years, and getting good science results from, very important science results. So yeah, it sort of ties into that whole planet debate, and so that's why that image actually came out several years after it was obtained. It was obtained, in 2003, and I guess it was summer of 2006 when we actually created and released the image that we were just seeing.
Cool. So here's what we're talking about, folks. I have a graphic up here that shows the various comparisons of sizes to different objects in the solar system. And Keri, can I get you to comment on this a little bit? You can see how big Ceres is compared to Vesta. What are these other things that are listed in here as well?
Yeah, so the other asteroids listed are some of the asteroids that we've explored with different spacecraft. So just to give you a different idea of the size, the diameter of Ceres is about the diameter of Texas, and Vesta, same concept but with Arizona. So they're really big compared to all the other asteroids that we've explored. And so all the other asteroids are just these little lumps of rock, but Ceres and Vesta are just completely different. And So Ceres is a dwarf planet, and Vesta is a protoplanet. It was trying to be a planet, never quite made it. So they're not quite just the lumps of rock floating around in the asteroid belt.
Okay, so there's lots of different sizes here, and obviously Ceres is the largest in there. Jianyang, can I get you to give us a comment on how important are these small worlds like Ceres in solar systems? Do they play any special role in the formation of planets, or are they just a byproduct of solar system formation? What exactly are bodies like Ceres?
Well, depending on how you think about these small objects, you get different analogies. Some people said, okay, these are the building blocks of the planets, of the planetary system, because in the early solar system, the dust that condensed out from the gas first made out of the small bodies, and then those small bodies accrete and grow, and to today's big planets. But then during this process, a large fraction of these small bodies are actually ejected out of the solar system, and also then there are some left. Most of them are in the currently in between the orbit of Mars and Jupiter, and those are what we know today as the main asteroid belt. And then those small bodies, they collide with each other, they grind with each other, and they become small fragments. So in that sense, you can say, okay, these are probably the junkyard of the solar system. But I would say that these are probably, I think the analogy I like the best is that these are the fossils of the solar system, because these are the old remnants from the formation of the solar system, and then they're preserved so well that we can still study it today to infer what's going on at the beginning of the solar system.
So I have a graphic up of what I guess you guys think Ceres is made of. There's layers to it apparently. Can you comment on this diagram?
What I see is a Hubble logo.
You do?
Okay, Jianyang, what they're showing is sort of an artist's rendering of the differentiation of the core of Ceres, so showing the thin, dusty outer crust, the rocky inner core, and then most excitingly, the water ice layer.
Right.
Yeah. Now I see it.
Okay, good.
I apologize. Probably because I'm using the Wi-Fi wireless today, and my internet connection is probably not that good.
Just blame the snow.
Anyway, now I see the graph.
It's okay.
Yeah, just blame it on the weather.
Yeah.
So this is an interesting diagram. So yeah, I'd like you to comment on it a little bit and maybe tell us how we know that, or why we think there might be these water ice layers in there.
Sure. Yeah. So at the beginning, before we know much about Ceres, everybody think, okay, Ceres, it's just a big chunk of rock, and it's the same everywhere inside, no matter whether you're sitting on the surface or you go into the center of the body. So that's what we call that undifferentiated. That means everywhere is the same inside. And then what makes it differentiated? That's, if it has enough, like we call that radioactive heating, then the temperature inside Ceres will increase, and then that will melt the material. And then different material with different melting point, with different density, they will sink to different depths. And that makes it differentiated. And we actually know this result from the Hubble data, from the 2003-2004 Hubble data that you just saw. And from that data, we measure the shape, we measure the density of Ceres, and then from that, people can make some models. And in the models, people think, okay, Ceres is most likely differentiated to a core, a metal, and a crust, like this, like what you see here in this graph. And also from that set of data, since we measure the density, and we have some idea about, the densities are like twice of the density of water. And then we also have some idea about what's the composition of Ceres, which is more like, carbonaceous chondrite, which is like carbonates on the Earth. No, not carbonates, but something like that, made of carbon minerals. Okay, so we know the density of those things are like 3. So that tells us that, okay, there must be something that's less dense than rock in Ceres, and most likely composition would be water. And so from those calculations, we thought that, okay, they should be like a quarter of the mass in Ceres made of water. So that's what you see here. And theorists, they came in and then they do some their models. Then they say, okay, so Ceres should have this water, above the core. The core is mostly like rocky and dry, and then the water will, be above the rocky core, and those water might be, liquid. And it should be liquid at the beginning when the temperature is high enough. And then as the temperature went down, and this water will condense and will freeze to ice. And that's what most water should be like today. It's a big layer of ice. And also, there might even be some small areas with liquid water. That's people are really interested, because if you have liquid water, then people are using their imagination. They will think, okay, there might be some kind of fish there.
That's exactly right. And so, that's exciting. I mean, that's really
well. And Max sent me an image earlier that I'm going to share here, just for comparison. Is the amount of water we were seeing there on Ceres compared to the amount of fresh water we see here on Earth.
Yeah, so this graphic is just showing how much water there is on Earth. This is from the USGS. I love this graphic that they've produced. It shows, that Earth really doesn't have as much water as you think. I mean, we know Earth is covered with 70% water, but really it's like basically paper thin. It's really not as much water as you think. So if you scoop it all up into a sphere, you see that all the water on Earth isn't much bigger than Texas, and all the fresh water is even smaller, and all the water, the groundwater is, including all the groundwater and things like that. I think there's 3 different blobs there reflecting different, depending on how much water you're counting. But one of the most.
So wait, hang on. The big blob is all the seawater, salt water.
I think that's all the water on Earth, whether it's in the oceans or fresh water or beneath the ground. You can read the.
Oh, okay.
I've never seen this before. It's all the water, including fresh water and salt water.
Okay, and then the little dot.
I think it might include groundwater. I'm not sure, but then the next one I think is fresh water, and I don't know what the smallest one is. It might just be rivers or something. But you get an idea that there isn't as much water on Earth as you might think just looking at the big blue marble.
Yeah, that's very illustrative.
One of the amazing factoids, you look at that diagram that we were just looking at of how much water ice is, that the simple fact that there could be more fresh water on Ceres than there is on Earth. That fact, at first when you first hear that, it sounds crazy. How can that possibly be true? But when you look at this graphic, you see it's actually not that difficult for it to be true. But nonetheless, it's still amazing if you think about how much finding water in the solar system is a driving scientific goal. That if Ceres is loaded with water as we think it might be, then it makes Ceres a much more exciting astrobiological consideration in the solar system, and it's much closer than a lot of the other places we're considering, like Enceladus and Europa and other outer moons of this outer solar system. So it's a kind of exciting that now there's this water world that's actually much, much closer. It's in the asteroid belt. So a little farther away than Mars, which of course is also very exciting and interesting and well studied. But I often think that, boy, I would love to send a rover to Ceres.
No kidding. Look at this. Jianyang's got a thing up here that says Ceres is about 40% by volume of water compared to very tiny amounts for Earth and Mars. Do you want to comment on that?
Yes, let me explain this figure.
Yeah.
Actually, we made this figure like last year, and we thought this is a very good illustration for relatively how much water Ceres might have. We have to say might have because we're not completely sure yet, okay, to be cautious. And and also I presented this figure in one of the meetings at the Space Telescope Science Institute. So what do you see here? There are 3 big spheres, and the blue one you not recognize, that's the Earth, and then the sort of a yellow-brown one, that's Mars, and then there's another small one, kind of reddish compared to others, that's Ceres. So, and the size of these bodies are on scale. So these are their relative size. And then we got 3 water sphere here. These are all the water that we thought contained by all these different bodies. So Earth has this much water, and compared to the total volume of the Earth, that's only like 0.1% of the Earth volume. And then for Mars, it has less water than what's on. And compared to total volume of Mars, it accounts for 0.05 volume percent.
Wow.
But then there's another water sphere for Ceres, and then based on our current standing, Ceres has 40% of its volume in water. I mean, I should not say this. Okay, sorry. I should say if we take all the water from Ceres out and make it a sphere, then the volume of that sphere is 40% of the volume of Ceres.
Okay.
That's a better way to say it.
Wow. I tell you what.
Yeah, and from here, what we think is that, you know, in the inner solar system, which we say is within Jupiter, okay, inside, including the main asteroid belt, including the Earth, Mars, and anything inside like Mercury, Venus, and anything there. And if you compare this graph, you get the impression that Earth has the most water, and then the next would be Ceres. So Ceres is actually the largest water reservoir in the inner solar system, other than the Earth. That's impressive.
Yeah, yeah, and I got to say, the real shocking thing was just that the percentage by volume of water that Earth has was I had no idea. I mean, you're right. You think, you know, all of the planet surface is covered, most of the planet surface is covered with water. You think it's got more than it does. That was a real eye opener. So thanks for showing that. So Hubble has set the stage for Dawn. It is imaged this minor planet and given us some data with which to work. And so I want to go move to Dawn now, but I want to start with a Q&A from Albert Bundy on the Q&A app, who is asking, will there, and this is a good segue into this, and Keri, maybe you can address this for us. Will there be a difference between what Hubble is showing versus what the new Space Telescope and Dawn will produce in showing detailed pictures of Ceres? So I guess the way I interpret that is, what will Ceres or what will Dawn show us that we can't see with Hubble? What are we hoping to learn? Are you there?
Yeah.
Oh.
So I think, you know, it's hard to say what new surprises we're going to have, but we're going to have such high-resolution pictures compared to what we have. And we were surprised at Vesta, even though we had Hubble images. And so I'm sure we'll be surprised with whatever Ceres has in store for us. And I like to think of Dawn as like a detective, and we have our instruments, and we're going to the scene, and we're going to investigate all the different things that Ceres has to reveal for us. So I don't know what Ceres has in store for us, but we'll find out.
Yeah.
I guess I will say that recently there was a paper released by the Hubble Space Observatory that found water vapor around Ceres. So Ceres has some sort of mechanism that's putting water vapor and causing kind of a thin temporary atmosphere. And my background is in meteorology, so I think it's very nice that Ceres decided to have an atmosphere for me. And so...
and Keri loves weather. She loves it.
Yeah, so
now I live in Southern California with no weather. But, you know, I think that we're going to try and look into this, and then we don't know what else Ceres will have in store for us. So I think it'll be a very exciting mission over the next year.
Awesome. Okay, so that was a good question. Thank you, Albert. I appreciate it.
Well, and I want to share an image real quick, too, just to give an example of what Dawn's do with Vesta. So here is an image, also in the festive season since we are in December. So here's a snowman on Vesta, but this was taken with Dawn. So this is what we've been able to see on an even smaller planetary body, but this is what Dawn is going to be able to see on Vesta, much higher resolution than we've been able to do with Hubble.
Right. So right now, Hubble is still able to do a slightly better job than Dawn is. But you were saying, by what time, Keri, will Dawn be doing a better job than Hubble?
January 25th. So
and you
a little over a month.
And you said it was going to be about 1.5 times better than the Hubble resolution, and then it's just going to keep getting better from there, correct?
Yep.
Okay.
And we at Hubble couldn't be more thrilled that our images are going to be very obsolete very soon. I think that's awesome.
I agree.
Because, of course, most of the solar system objects we observe with Hubble will never be visited by a spacecraft. So when they are, it's really exciting.
So while I got you up here, Max, let's go back to the data for a minute, for Hubble data. You've got some raw images, right, of what these data look like. Can you just kind of maybe share with us a little bit about how this stuff comes off of the telescope? I know we've done this before, but not everybody has seen every Hubble Hangout, so it's always nice to show people what Hubble gives us and what you what magic you do with it.
Sure. Yeah, I actually didn't have the raw data sitting around years ago.
Sorry.
But I did just get some, and I pulled one up. I'm not sure it's the best example, but I'll do a screen share here, I guess. So yeah, I mentioned that there was quite a bit of work to turn, the raw images into. There's screen share. Okay, let me know if you're seeing an image here.
Okay.
You got it?
Yep, I got it out.
Okay, so a not so impressive image of Ceres here from 2003, where a couple of things. First, it looks like an egg.
Yeah.
Because Hubble produces distorted images. It's one of the ways we're so sensitive is that we minimize the number of reflections, and so we don't bother to do an extra one that would then undistort the image, so we have to undistort the image in post-processing. You also notice a whole bunch of flecks in the image. Those are cosmic rays, which are just flying around space, high-energy particles that just go shooting through every single image. So we have to have ways to clean them out, and generally we take multiple exposures and combine them to get rid of the junk. And in this case, so I mentioned that we took a series of images and shifted them each a little bit. So if I zoom way in, you can actually see the individual pixels. Kind of starts to look like a pile of Legos. You start to see the individual pixels, and if we do little shifts on the order of like half of those pixels, we can actually sample the image. You can see I'm trying to stretch it as best I can, and you still can't see many surface features like this, and it looks very, very pixelated. So that's kind of what I'm starting with, to sort of clean up the image, undistort them, combine them at a smaller pixel scale, so extracting as much spatial information from each of the individual images, and then combining it into that high-resolution image that you see in that nice color press release image. And of course, then we did 2 filters so you could get a nice color image. So that just gives you an idea of what the raw data comes in. It doesn't come shooting out of the telescope looking like the press release image. There's usually a fair amount of work.
I always like to point that out when I have you on the Hangouts, because you do, you're not inventing anything, but you're removing artifacts and you're trying to get the details, the actual science units teased out of these images, and I always like to bring that up. Keri, I have a question for you, and this may not be a fair question, and I hope I'm not putting you on the spot, but how do the cameras on Dawn? Do you know how they compare to the cameras on Hubble, or are they higher resolution? Are they different wavelengths?
So the cameras on Dawn are called the framing cameras, and they're provided to us from DLR and Max Planck in Germany. And I don't know specifics of how the optics compare, but I know that we will have some gorgeous images coming out of them.
What wavelength are they visible light? Are they infrared? What wavelength ranges do you have there?
So we have a filter wheel in front of it, so we can pick a couple different filters. So we have some kind of in the visible range and some of the near infrared colors, and then we also have a visible and infrared spectrometer that can get more of the infrared data, and then we also have a gamma ray and neutron detector, or GRAND, and that'll be able to see kind of in the gamma ray neutron range. So we can basically see a whole bunch of different wavelengths of light with our different instruments that we have.
Okay, that sounds so. And these are relative, and because of the proximity of Dawn to Ceres, you'll be able to get a lot of high resolution images from that. Let me get back to the Q&A app. We've got a couple of good things here. Eric Charland is asking, what does Ceres miss to be qualified as a dwarf planet? I think it is a dwarf planet, isn't it? Jianyang?
Yeah, Ceres is a dwarf planet.
Yeah, so I think it is one. It doesn't miss. It is a dwarf planet. But thanks for asking that, Eric. And
so maybe he's asking missing to not be classified as a true planet.
Oh, okay. All right, well, maybe we should comment on that.
Because Mike Brown's out there just killing all sorts of things.
Yeah, he's killing all. That's right. He's killing all kind of planets. Let's talk about that just briefly. And I don't know if Jianyang or Keri, if you want to take this, but what is the limit? What's the limit? What's the deciding factor on whether it's a planet as a planet or a dwarf body?
Well,
go ahead, Jianyang.
Okay. So basically, to qualify to be a planet, I think there are 3 criteria. One is that it has to be circling the sun. That's easy. And second is that it has to be big enough to maintain a round shape. That's not very easy, but Ceres made it. And then the third one is that you have to clear your neighborhood, which means that you don't have any small, many more junks around you, circling the sun in orbit very close to you. So that's the three criteria. And if you only satisfy the first two and not the last one, then you are a dwarf planet.
Well, there's another one. I think, like Scott said, Mike Brown has to approve. But
Yeah.
okay, so here's a good question from Albert Bundy. And maybe this is also for you, Jianyang, I'm not sure. Is the gravity of Ceres enough to attract more surrounding rock and able to grow in size and mass? I think one of the criterion you just mentioned kind of answers that question. But is it able to grab more stuff?
Well, let's see, how do you answer that? Okay, if you have enough mass, then depending on the how much material around you, you either grab them and grow yourself, or you either kick them out. At the early stage when you have enough material surrounding you, then mostly you're gonna grow. You're gonna attract more material and accrete more material, and you grow yourself. But then when there's not much material around you, and then when the relative velocity between you and your those small junks around you are high enough, then what you do is that you actually eject those objects. You get rid of them. You throw them out. And so the third criteria, that you clear out the bodies around you, that's actually talks about the last stage, when you actually eject those junks away from you. And the mass of Ceres is not big enough to eject enough material around it to clear its orbit. Yeah, although it's much massive than other asteroids, it's still not massive enough to do that job.
Good question, Albert. That was really relevant to what we were just then talking about. So that's really good.
That said, though, there can still be fresh craters on Ceres when Dawn gets there, not because Ceres gravitationally pulled anything onto the surface, but there's collisions. Most of the collisions happen in the early solar system, but there is still the possibility that smaller asteroids could crash, just crash into the surface of Ceres. Again, not because it's being gravitationally pulled in, just a simple collision. We see other collisions of asteroids going on. It's rare because the asteroid belt is much emptier than most people think it is.
Yeah, it's not like that. Star Wars. I was gonna say that. Yeah, it's not like.
But nonetheless, we do know that there are still collisions, currently happening, and there's pretty good reason to expect that there will be relatively fresh craters on Ceres.
Yeah. So, Keri, I want to ask you a quick question about the specifics of the science goals of Dawn with respect to Ceres. Can you give us some specific things you're hoping to do and learn on this visit? Hello?
They look frozen. I don't know if we lost them.
Oh, okay.
No, we're here. You froze.
Oh.
But maybe you froze.
You froze in relation to us. Did you hear my question?
Maybe. Saw that snow going on.
Yeah, really. I was asking about the science goals of Dawn. Can you give us some overview of some specific science goals that you're hoping to achieve when you reach Ceres?
So kind of relating to Dawn as a detective, we're going there and we want to map the entire surface, and we want to get good pictures of the entire surface and kind of make a map. And with that, you can get the topography, you can get the geology and the geologic units, which is basically the type of rocks that are similar, and you kind of group them together. And you can actually see on Dawn's website right now, dawn.jpl.nasa.gov, we have a link to the Vesta geologic maps. And so we'll also, with the other instruments, we'll be able to get mineralogical information and also elemental composition. And given all of those things, it'll give us the big picture. Oh, yes, so this is a globe of what, this is the topography of Vesta. So Vesta isn't round, so this kind of had to be squished to make it into a round shape. But we'll be able to have something like this for Ceres, too.
Okay.
And I'm taking this home with me. Totally taking this home with me,
Boy,
too.
Scott, you're just going to rip
all this
off
swag at
JPL.
JPL is great.
I know. You're going to be like taking all that stuff away. So, So Cecil Morgan is asking on the Q&A app, and then I'm going to go to the YouTube comments and see if I can find anything there. Let me see here. Will Ceres be closer to aphelion or perihelion when Dawn arrives? And will it monitor changes in Ceres over a full orbit? Keri?
So when we get to Ceres, it's moving away from the sun, and we'll be moving away from the sun for the rest of the mission. And so that also ties into that water vapor paper, because they found a strong dependence on distance from the sun, and the closer they were to the sun, they saw the water vapor, and the further they were away, they didn't see it.
That was the Herschel observations, right?
Yeah.
Yeah.
So when we're getting to Ceres, it's past that point already, and it's only going further away. So it'll be very interesting to see if we see it, and we don't know if we will or not, but we're definitely going to look for it. So.
Yeah, good.
Yeah,
good
to
question.
add, can I add something?
By all means.
Yeah. So Herschel observed the water vapor around Ceres, but right now there's only one shot observation. So one people were thinking what could be the possible reason for that sublimation, and one reason is like comet. When they get close to the sun, they sublimate. When they get away, they don't sublimate. And if this is the case for Ceres, then by the time that Dawn gets to Ceres and around Ceres, then Ceres is quite far away from the sun. Actually, it's near it's going to its aphelion. So in that case, we may not expect much water vapor around Ceres. However, there are other scenarios that can make water vapor, like like what's happening for what's happening for like volcanism. If there's some kind of internal heating, then that drives out water. Then, since this is internal heating, it does not depend on water. Does not depend on solar heating a lot. So this will have weak dependence on the distance of Ceres with the sun. So if this is the case, then we might be able to see something. So that's why there's actually Dawn has another right now. This is also one of Dawn's tasks, to try to see what water in Ceres is really like, and how much water does it have? Really 40%, or we are wrong? And also where are this water? Are they very deep inside the surface, inside in the interior, or they are very close to the surface? And also what kind of activity are there? So by observing water, whether there's any ice on the surface or very shallow beneath the surface, we're actually trying to answer this question too.
Great, man! You guys are asking some great questions. I'm just going to keep going here. I like this one. Jorge Lima on Q&A app is asking, "Hi, Rosetta analysis on the comet 67P water showed that it's different than the water on Earth. I did not know that. Will Dawn also makes a similar analysis on Ceres water?"
That is a good question. So our grand instrument does elemental composition, but it can only see a little bit into the surface. So if this water is too low below the surface, it's not going to be able to see the water. So it's really going to depend on how close the water is to the surface and the ability of our instruments to see it.
Okay, so the good question. That is interesting. So I think it's Wout van der Heide. I'm sorry if I'm messing up the pronunciation. This is also Q&A app. This is, I guess, it's timely since we've talked about this for most of the hour. How will the NASA Dawn mission end? After studying Ceres, will the probe just will it just be sent in a trajectory outside our solar system? Will it keep orbiting Ceres, or can we try a soft landing on Ceres like the one that's being considered with Rosetta?
So the plan with Dawn at the end is that we will stay in our lowest orbit, the low altitude mapping orbit, forever. And the reason that we don't want to touch Ceres is because of all of that water. And there's this thing called planetary protection, that we don't want to interfere and touch any water.
Prime directive.
Yes, yeah. Basically. So we want to basically stay safe and stay in our orbit and just kind of orbit Ceres. So it will be a lonely moon orbiting Ceres forever.
Oh, that's nice. Nice. Kind of a nice image, though. But
well, sorry, Tony. One thing I learned a while ago, which I was surprised to hear, is that apparently early on there was a chance that Dawn could go to the large asteroid Pallas after Ceres, but I guess because of launch delays, that opportunity was lost. And so it's heartbreaking, to hear that.
Yeah.
But it does make you realize, as Keri was describing at the beginning, that I guess there's always, even if you stay in sort of a stable orbit for even a decade, is there a possibility that if there's funding and an object to go to, that you could, flip the switches back on and say, okay, we're leaving Ceres orbit and going to another object? Or is it just that there's no really interesting objects, within reach?
Yet another advantage of a ion drive. Is that possible, Keri? Can they just do that if they decide there's something else to look at? Do you know?
We didn't catch that. That cut out for a second. What was
Sorry, is that true that you can maybe just after if you see something else interesting, you can just turn on the drives and
does it remain possible to depart Ceres ever in the future?
Yeah. That's a good question.
So the reason that we will not depart Ceres is because we had 2 of our 4 reaction wheels fail, and so to turn we have to use also our hydrazine thrusters in addition to our reaction wheels. And so for us to stay there, we wanted to make sure we got Ceres done, and that's basically going to use up the rest of our resources, so we won't be able to turn anymore. And if we can't turn, then we can't turn to send all of those pictures back, and we can't turn to take the pictures. So.
I swear, reaction wheels and awesome missions are just going hand in hand with not going well. We need to find a better.
I know these reaction wheels seem to be the Achilles heel of most missions these days. But that is a neat idea, Max. That would be cool if they could do that. Okay, so finally, I'm going to go over here and look at my YouTube. Okay, so here's one from Enrico Gatto from YouTube. I'll just put this up real quick. Is Dawn going to visit any other body of the solar system after Ceres? Keri just answered that. Sounds like it's not going to go anywhere. Let me see. Cage Crave on YouTube. Can you point your telescope on our binary dark star companion? I don't know what that. I don't know what that means.
The dark star yeah, that's like with the red matter from Star Trek, and I think we can just go along from there.
Okay, yeah. So there we go. Okay, so that's from YouTube.
Yeah, thank you, YouTube.
Yeah.
Great.
So this is what I get for not having a director right now today. So okay, so I think do I have any? Is there anything from Twitter, Scott, that I'm missing?
I've been trying to monitor Twitter. There's been a lot going on. First of all, I do want to give a shout out to the Dawn EPO team. They've been great with tweeting out as everything's going on and interacting with everyone there. But people are having just some great conversations about the amazing images that have been going on and sharing out our show. So we really love that, and all the great retweets and the love of the images that we've been sending out too. So I've been tweeting out as Hubble of the different images we're going out there. So there's been a lot of great stuff. I'm going to head over to the event page and see what else we have going on the event page as well.
Yeah, check that out and let me know if you see anything. Max, I'd like to ask you a quick question about, is there any future role or any plans with Hubble that you know of to maybe observe Ceres in conjunction with Dawn, or is Hubble pretty much done for now with its participation? Do you happen to know?
Well, there is some data that we're working on right now. I mean, there's been some observations last spring. I mean, one of the things we've done for Dawn for both Vesta and Ceres is search for moons, and we're still working on that. I think but of course now the Dawn spacecraft is going to be able to do that even better. So, but it's the same people who've been using Hubble, and now I think we're transitioning to a moon search with the Dawn spacecraft as it approaches. So just before it goes into orbit early next year, and so we're still working on that problem. We've done many searches, so I think if Ceres had a big moon, we'd know it by now.
Right.
So we're kind of like scratching in the dirt now to try to see if there could be a small satellite around Ceres. And I think depending on what happens, with discoveries of Dawn at Ceres, there could be some kind of follow-up or some complementary observations that could be done with Hubble, possibly. I think it remains to be seen, but it would be driven by discoveries at Ceres.
Okay, all right.
Actually, Hubble is not done yet. Hubble will do some more observations Hubble will do some more
If you have
observations
anything to
that
do
Dawn
with it,
cannot.
right?
Right. I believe, Jianyang, that you'll be still observing Ceres from Hubble for quite a long time, right?
Well, we actually have another observation from Hubble on Ceres, which will be next year. Next year in June, and that is actually in the UV, because Dawn instrument is not sensitive to UV wavelength, which is the the UV wavelength. UV is what everybody doesn't like, and so you cannot do that from the ground.
What everybody does not like, you said?
Yeah, because everybody use sun blockers to block it.
Oh. I see what you mean. Yeah, but you bring up an interesting point.
Yeah.
Hubble, if you want to see anything in the UV from a space telescope, Hubble's the only game in town. That's the only.
Exactly. Actually, you cannot do that from the ground, just because our atmosphere actually blocks a lot of UV already.
That's
so we
right.
cannot do that on the ground. And
But
Hubble
that's
is
a
the
good
only
thing.
instrument that can do it. Yeah, and so that's why we're going to do
There's
this
a good
UV
question
operation.
here from. There's a good question here from the Google Plus event page, which might cause a minor fight to break out here at Jet Propulsion Laboratory. Is that if significant water is detected on Ceres, would that minor planet or dwarf planet become as important as Mars is now for NASA in the future? I am sure that could cause a fight here on these grounds, but I'm interested to hear what you have to say about that, and then I'll talk with our Mars friends afterwards.
So we're not in competition. We're all one big happy family here at NASA. And so, it's really up to the scientists and Congress to identify the priorities and come up with the budget for it.
And that's one thing that's always great to do, is rely on Congress to make great decisions for us for science.
Quickly, that's right. I just want to say the opinions expressed by Scott Lewis are his own and not
I have an independent contractor, and it's okay.
All right. This has been awesome. Well, I will say one thing. We've had a lot of live viewers on this Hangout. It's been really great having you guys there. I'm still... here's one from Zigzag. Let me get to that real quick. Does Ceres have a gravity and atmosphere? Also, any indications of ice on the surface? Gas emissions coming from Ceres? We've answered some of that. That does have gravity. You can be sure of that. And Keri mentioned something about atmospheres. And is there any indications of ice on the surface? Are we sure of any ice on the surface, guys?
Not yet.
Okay, not yet. We'll need to
not
get
yet.
those pictures.
Right now. Exactly.
We need to get those pictures from Dawn to find that out. And as far as we know, no gas emissions.
Well,
I was going to go somewhere
actually,
with that, but I won't.
really research observation show that there might be some water vapor. I mean, there are some water vapor on Ceres, but very, very small amount.
So there you go. Good question, Zigzag. Thank you very much. Okay, so let's see. I guess I'm trying to see if I'm missing anything. Scott, can you tell me one more time if you see anything?
No, I think we've got them all, and we do have a few things to mention too, as far as, since this is our first really big, which I'm really happy to be a part of, a collaborative Hubble hangout with other science missions. I do want to do a quick shout out again to everyone at the Dawn team, including Keri, whom I just happen to be friends with, but everyone also at the Dawn team, the science team, the outreach team. There is an event coming up on the 9th of May of next year called IC Series. There's a link down here, and I'll put this into the event page, but it's a bit.ly link, Dawn_I, the letter C, series, and you can find out more about what's going on. They'll be here in Caltech, but people can start up their own private events across the world, and I might actually be attending that too here for different reasons. But it's something that's there's a lot of things going on with Dawn, and I definitely recommend going to the Dawn website, which can be found where?
dawn.jpl.nasa.gov.
Very nicely done. Very well done. And I just want to echo what Scott said. I am happy to be working with other NASA missions to the extent that Hubble is able to contribute to their science. I really want to do more of these. Keri, can we have you back when we get close to Ceres? Hello?
Oh, I don't have my Ceres model here.
You froze, so Keri, can you do something with Ceres? Are you saying can we have her back when we're closer to Ceres?
Yes, when we get closer. It's maybe sometime early next year.
Yeah. So we will enter our first science orbit at the end of April. So we will start having some fantastic images at that point.
Good. I hope to have you guys back. And Jianyang and Max, I want to thank you both for giving us the Hubble contributions. It was really wonderful having you back. As always, I enjoy having you in my Hangouts. You're always really great. So thank you both for showing up and contributing. I appreciate it. You'll come back and join us again for future ones. Maybe when we do some comet stuff. Who knows? Next week, we're going to be going to the Intrepid Museum in New York, where they are having the Hubble at 25 exhibit. We'll have astronaut Mike Massimino with us. He will talk to us not only about the exhibit, but about being a space shuttle astronaut, about all the experiences with Hubble. He was also one of the ones that worked on Hubble, so he can give us some background on that. So that will be next week at our regular time.
I'm so excited about that.
Yeah, me too.
When that was first told me that we were going to have that, I kind of squeed. Okay, I really squeed. I was really excited that we'll be able to talk to one of the only human beings that has been in space that has worked on the telescope that we get to talk about every single week. So that's really cool.
Yep. So as Scott mentioned, I want to thank everybody from the NASA Dawn mission. I want to thank you, Keri, Max, and Jianyang for taking time out to do it. Carol will be back next week. She couldn't make it because of the time change, the time difference. She couldn't attend this week, but she will also be back next week. And so thank you all for watching. Thank you for commenting. Thank you for questioning. And as always,
keep looking up.
There you go. Talk to you guys later.
Science.
Bye. Science.